Good morning, everyone. Welcome to our new Thursday sessions that we're doing here at the lab. I am Katie Sealing and sort of the behind the scenes person. If you notice the head that's not talking, that's not me. I'm not sharing my screen right now. That's Eric. He will be your teacher today. You are signed into lighting, retrofits, and audits. It's an overview class, so I hope you're in the right place. Eric, you want to advance the slides? I'm just going to give a little, state of the webinar here.
Sure. Let me make sure I have that capability. Why not? Let's see. Let's try it this way. Stand by. Okie dokie. Maybe I'll try over here. There we go.
All right. So if you haven't attended one of our webinars before, you're muted, but we do have the chat feature enabled so you can send questions at any time through there. We'll see them. I think there's some pauses for breaks that Eric can answer questions. If we see anything really, need to answer right at the moment, I might break in and pause Eric. We also have some polls to participate in. They're just kind of fun and help Eric gauge what, kind of the content needs to go over for this class. And at the end, there's a short survey, and it's being recorded. So this recording will be posted to our website in case you have to leave or if you want to go back and review some of the information. Give us about a week to get it posted, but you can reach out to us anytime after this at lightingdesignlab@seattle.gov. And just a reminder, we are called Lighting Design Lab, but we are Seattle City Light employees. And we can probably skip this slide. Some of this stuff is not available anymore. We no longer have a facility. Well, we will get one another time. We just don't at this moment. So we don't have a lot of technology evaluation available, but we are continuing our education and training and expanding to other means of electrification as well as the lighting and controls that you are very used to. And without further ado, here is Mr. Eric Strandberg.
All right, thanks, Katie. Appreciate it. And just a little note on some of those things. Yes, it's true. We don't have our demonstration facility, but we can still do a little technology evaluation. If you've got, excuse me, something that you're looking at and you want an opinion on it, you can still email us pictures or cut sheets or anything that you're wondering about, and we can offer an opinion if that's relevant. So still reach out if you're looking at technologies. But let's launch into the presentation. I love this picture because it lets me know, it keeps me humble. Lets me know that lighting is not the highest priority for everybody. So this was in a little cafe, and they thought the radio was more important than the light. So they unscrewed the bulb and put in a little socket inside that light so they could plug in their radio. And I get it, so I think we need to keep that in mind when we're approaching customers and looking at projects, and we'll see as we go that that's something we want to look at. As far as myself, hopefully I've had a chance to meet with some of you. I've been around at the lab since 1995. So I've been doing all things lighting for quite a while. We're getting into controls, and we're also pivoting to things besides lighting, and we'll be going through a rebranding in the coming year. But yes, if you have any questions, my knowledge is, as they say, a mile wide and an inch deep, although it's more than an inch deep in some areas. So let's see what happens. Anyway, here's another fun picture. One of the things that's great about lighting is you can look at it all the time and it's everywhere. It's maybe a bit of a curse. This was a crazy little retrofit I saw where they had that would have been a 2x4 surface mount parabolic type of fluorescent fixture. They didn't want the fluorescence, so they cowboyed in a little track fixture in there. I just loved it. Anyway, we're going to look at this is a class about retrofits, but it's also about audits. So when you're going into a space, you want to look at what's there, either physically or virtually, and you do find some pretty amazing things when you start looking at buildings as they age. And this gets you to not only do you want to look at drawings, you want to look at as-built, but you also want to look. It doesn't hurt to have some eyes on the ground and see what's actually there. We're also one thing we're going to look at as a little bonus at the end is a little thing on Luminaire level lighting controls fixtures. They're a pretty cool innovation. So here's our first quiz. And I don't know, Katie, are you going to go through the dot points or how are we going to do this?
Yep, let me launch this poll here.
Great. I
Launch.
should know by now.
There we go. Well, we haven't done this class for a while, so yeah, that makes sense. So here is a poll. Go ahead and click which applies to you. How many of you have done lots, do some lighting but want to know more, are a contractor but want to know more, are new to the field, or how many thought this was a cooking class? Those of you who choose this are welcome to stay. You might learn something interesting.
Yes.
And I'm going to leave this open for just a couple more seconds. And 3, 2, 1, close. All right, so Eric, it looked like there were about 60%. They are lighting professionals that want to know more. And several are new to the field as well. 20% did think this was a cooking class, or at least enjoyed that answer.
Okay. Maybe if we take a break, we can share some recipes. Anyway, right. Thanks. And just FYI, Katie, I can't really see the results. So yeah, it helps if you can kind of talk me through the poll results.
Yep, no problem.
Great. Okay. So this slide and the next slide seem similar, but they're actually a little different. So this slide, it's really important to figure out what the goals of the project are and your client. A lot of people say that, hey, we want to save energy, but what they really mean is they want to save money, and that there's nothing wrong with that. I mean, saving energy can save you money. But if your primary goal is to maximize the dollar savings, and that just makes good business sense on some level, so there's nothing wrong with that. That may put you down one path, whereas if energy savings is primary, that might put you down a slightly different path. I could walk into almost any building, any room, and save some energy. It may not save money. It may be, maybe it's a relatively new building, but you could probably carve out some energy savings. Another motivation might be a productivity enhancement. Maybe the lighting is poor and they feel like it's getting in the way of a safe and productive work environment. So that's their main goal. So you walk in, you see lighting, and they want to change it. To make it better. Maybe it's just a question of timing. It's an old building and they just need new lighting, and they brought you in to help them with that. and it also could be that they're doing a remodel, and because of the remodel, they have to upgrade the lighting. So they didn't necessarily want to change it, but they have to. So these are all nuanced questions that will you should answer. Now, admittedly, in any project, you could do some or all of these. Ideally, there'd be some dollar savings. There'd be energy savings in a new system. It would be hopefully better lighting, or at least as good. So, it's not a case of just picking one. Now, related to that is, what are the priorities of the different constituents, especially on a big commercial project, or even a not so big commercial project? You're going to have an owner of the building. Potentially, you're going to have maybe some tenants. Maybe there'll be engineers, or possibly architect. Contractors brought in to help with the project, and they may all have various priorities for how they want the thing. The owner maybe just wants long-term. They're thinking long-term. They're going to own the building for a while. A tenant is concerned maybe about bringing their clients in, and how the space appears and what they can say about it. The engineers maybe are taking a more approach of, they just want to maximize the energy efficiency. Contractor, they may assume that the lowest first cost is what's important to everybody, to particularly the owner, and that may not necessarily be the case. Facility operator wants low maintenance, so they may be reluctant to try something new. They may be dragging their feet. If it's left up to them, they'll put in what they had before because they know how to work with it. The users of the space maybe don't really know about it. They just want it to be good, as a good lighting. And architects, we find often are, they want something that's going to match with how they want the space to appear. And so the appearance of the lighting, or how the lighting shows off the architecture, may be of a primary concern. And again, hopefully everybody gets what they want, but it's not a case of whoever's speaking the loudest necessarily gets their way, except possibly the owner, since they're usually paying for it. I've been brought in on projects where, they're like, yeah, we're doing this retrofit of this building, and it's just really hard. And it turns out that they brought you in with the hardest part. That maybe 80% of the building is pretty simple, but there's a couple of areas that are really challenging. So you don't want to necessarily get too hung up on those really hard sections. Focus on the relatively easy parts. Get those done. Get those figured out. And sometimes they'll be like, well, we want to change all the lighting. And, I've been on projects where some of the fixtures will be almost impossible to change without a really a lot of effort, a lot of money. And so you need to say, are these really important for you to address? And they may be, but it may be that you don't want to hold up the entire project based on just one or two fixture types. Additionally, sometimes you're walking around the space and you're getting an idea of what's there. And you have to decide whether you need to do a full on audit, or you can just get most of what you need by a simple walkthrough. And the other thing, again, I'll keep coming back to this, is you always want to ask, how does the client like the lighting? Is it working for them? Is it not? Katie, can you see my little red dot here? I'm
yes,
using
I
a pointer.
can. Yep.
Okay, just want to make sure it's visible. Sometimes I've not initiated, so let's so let's see here. All right, looks like it's one or the other. So maybe what I'll do is dispense with the pointer. So determining whether a retrofit is cost effective or, is going to be dependent on a variety of things. So here's a case where we've got this is probably an 80s vintage, it looks like some sort of server room or computer room. You want to look at the hours of operation. This could be a 24/7. There's people there. The lights are all on. They need lots of light all the time, every day. How old is this system? If it's an old system, chances are there's going to be room for improvement. Technology does move on. You could find out if there's different rates that the utility has, and if there's an opportunity to put in some controls so you're adjusting the lighting for different times of day. Are there higher light levels that would necessarily be required? I mean, you can walk into a very brightly lit space and you adjust to it. But if you were to cut the light level in half, it still might be brightly lit. You could have 100 foot candles in here in that space. And if you had 50, it would still be plenty adequate by most standards. So it doesn't hurt. We'll talk about some metering and some field things that you can use. If you've got incandescent lamps, which I still see from time to time, and then are there other energy saving opportunities? I've been into spaces where there were skylights that had been boarded over for whatever reason, and that would be a way that they could bring in some high quality light and maybe add some savings as well. And so additionally, can there be controls? It may be that after hours in a space like that, maybe there's someone that just comes in every 2-3 hours and take some readings, and then they go off to some other place. So you could have occupancy sensors so that when they're not in there, you're not using power. Another thing that doesn't hurt to ask is, has anyone done an analysis of how much they're paying for their lighting? It may be that they are they just pay their basic electric bill, and they don't know really how it's parsed out from lighting to motors to refrigerants to air conditioning, other things on the facility. So it doesn't hurt to have that conversation. If it's not cost effective, that could be, there could be a variety of reasons. Maybe this facility has pretty short hours of operation. It may be that it's already a fairly green building, for whatever reason. It doesn't use a lot of power. So changing the lighting, you may want to change it, but it may not save a lot of energy. Or perhaps it's undergone a retrofit recently. I walk into spaces and I'll see maybe they've done a few different retrofits over the years. And so it's already got fairly modern lighting. So here's an example of two kinds of spaces. So here we've got a big arena with, these could be 1,000-watt spotlights here. And then you've got a community center that's maybe got, 150-watt little high bay type lights. So which do you think would be the best candidate for high savings on an annual basis? And surprisingly, the arena, even though it's got a very high load, maybe is only powered up, a few dozen times a year, and then for some special events. Whereas the community center is, they're 18 hours a day, maybe 7 days a week. So they're using a lot of power. Similar case here, we've got a nice office lobby using lots of, let's say, power, fairly high power density. And here's a hotel lobby with a similar power density, which would be the most likely candidate. Most of you probably know that, hotels, this lobby probably looks this way 24 hours a day, 7 days a week because they're always open. They might have a nighttime look that's maybe for, from midnight to 6 a.m. or something, but probably not. So long hours of operation in both cases here of the community center and the hotel lobby. So a detailed audit might be in order, and there's a variety of ways you can do it. You can look for plans. You can, look when you look at the plans, see how many similar spaces there are. If you've got, say, a school, there's going to be lots of classrooms, so you don't have to necessarily go into every classroom. You just need to maybe find a few examples. But if it's a complicated type of building, you might have to look at every building, every space somewhat uniquely. Look at the circuiting, find out, are there code or building standards or recommendations that are going to be come into play once you start to do a major change. So some tools that you'll want to have or that'd be helpful, light meter. I personally don't live and die by what the number the light meter says. There's a wide range of usually what's acceptable, but I think a light meter is helpful to give you a basis of, what do you think is going to be appropriate, how it measures up to current recommendations. Measuring tape or a laser, lasers are good, but I've found, especially if you're doing exterior, a big parking lot or something like that, during the day, that little laser pointer won't really show up. So it'll be hard to get a reading of, how high the poles are, how far apart they are, that kind of thing in a brightly lit environment. You might have to come back at night or use a tape. Notebooks are good. Tape recorders, sometimes people just walk around and they just talk into a little recorder, hopefully that has a transcription application. Camera with a zoom, I'll talk about that. Binoculars are good too. And then various personal protective devices, earplugs, hard hats. Don't assume they'll have earplugs. A counter, a little hand-operated counter, perhaps. And then, if a rebate is important to them, it doesn't hurt to have utility information with you as you go, just so you have a clear idea of how they're going to want to see that documentation. So you want to go out and check what the light levels are. You want to look at the different types of luminaires that are present. Sometimes you'll see the same fixtures mounted different ways. I've seen cases where you've got, usually this would be for kind of industrial type facilities, but where you've got strip lights or maybe wraparound type fixtures, and they're mounted on chain or stems. They're mounted on the surfaces, they're mounted on the walls, ceiling mount, all kinds of applications, but it's all really the same fixture. Doesn't hurt to know that. The different lamp types that are there, even if you're changing it out, say from existing lamps to say LED, it's good to know what they have so you have an idea of where you want to be at the end. Ballast types, voltage types, are there daylighting opportunities and are they being utilized? Again, if the existing fixtures have been modified in any way, what controls are there? And then room reflectances, and we'll talk about that in a bit. Beyond what's out there, what's the general condition of the facility and the lighting in particular? If the fixtures are old and possibly faulty, you're really looking not at a retrofit of the fixtures, but you're just removing and putting in new ones. Are there daylight opportunities? Are the fixtures on when they should be off? Are they off when they should be on? Things like that. General condition of the space will be helpful. Okay, another poll.
All right, let me open this. Which of the following suggest, oops, that a retrofit is likely to be cost effective? Select your answers now. Give it a couple seconds longer.
And in some of these, there may be more than one right answer.
Oh yeah, this is select all that apply. Okay, let's see what the survey says. Oh, I think I can share the, yes, there. Eric, can you see this screen that shows the results?
Oh, yeah, I can now.
Okay.
But it's tiny. And now I can't see myself, but that's probably for the good. But yes, it looks like facilities long hours of operation, yes. Measured light levels are higher than recommended practice, yes. Let's see. Yeah, so community theaters, 50, 500 watt lights, that seems like a lot of load, but they're probably only doing shows a few times a year for small, not that much at a time. So you have a couple of weeks at the most. So not a great hospital parking garage with 30-year-old lights, aging infrastructure, good candidate. And then customers going for LEED EB. I probably should have said that's LEED existing building certification. So yeah, they're going to need a lot of help. They're going to need to change things, I would imagine, if they want that credential.
Alrighty.
All right. So you want to document the existing light levels. What is being proposed. And I've been on projects where they're just like, oh, we need 100-foot candles. They're just sort of picking a number, a high number, and it's like, well, okay, just at some point you may want to look at that. What is that based on? Or sometimes they have a basis that's based on a recommendation that was 50 years old, and times change, recommendations change, even so it doesn't hurt to find out what the building standards are and what they're recommended on, what they're based on rather. Are light levels consistent throughout the space? Maybe they're picking one or two dim areas and say, yeah, we need more light everywhere, and it turns out that they need more light somewhere, but not everywhere. And are the users happy with the light level? And then what do you think? You want to walk in, and what's your general impression? Is it like, oh, this is nice and bright, or this is way too dim, or it needs to be fixed? So documenting the luminaires and even doing some research while you're there makes sense. And I mentioned a camera with a zoom, and everyone's probably thinking, well, I got my phone and it's got a zoom on it, so I'm pretty good. Here's a case where, so here's a fixture, and we can zoom in on it and we can see a label. Look at that. It would be nice. Sometimes as-built, sometimes it's hard to determine, especially in older buildings, what's actually there. So I'm zooming in, and once I put this on my computer, I can't really get any information from that label. But if I use an actual zoom lens, this is just a little, Instamatic type camera that you can keep in your, easy to carry with you, keep in your pocket. I can zoom in on that label, and then once I put it on a computer, I can zoom in again, and I can tell a lot about that fixture. I can tell the model, who makes it, something about the lamping. So there's lots of good information that you can have there that might be difficult to find otherwise. I think here's another case where, the client, these were some canopy fixtures, metal halide, and they're like, oh yeah, these are definitely 100 watt. I think maybe they're 150. Well, it turned out they were 70 watt. And part of the assumption if you go based on what they say, you'll react to that. You might put in a system based on what a 100-watt metal halide would do. Plus, it'll also affect their potential savings if they're looking at rebates or even just how much they think they're going to save. But what they had was actually 70 watts. You can zoom in on that label on that old fixture and see. So again, it doesn't hurt to have some equipment with you to do that. It would have been a long time trying to find a ladder that we could get up on to look at that. It would have been another trip back to the site. The thing you want to be aware of is what type of fixtures are out there. All of these fixtures look really different, but in my opinion, they're all sort of the same. They're all direct luminaires. They take light and shine it directly down into the space, whether it's a recessed can, a high bay fixture, a recessed fluorescent troffer, or a decorative pendant with metal shading. They're all direct luminaires. We often see indirect luminaires where the light is shining indirectly into the space, whether they're mounted on the wall, a linear type pendant. Even if it has a little bit of glow on the bottom, doesn't mean it's not getting most of its light up into the space. And the reason that matters is because your surfaces in the space are going to be particularly important if they either have indirect lighting or they're changing and they want to go to indirect lighting, but they're not addressing the surfaces. We'll talk about that later. And then there's various variations on direct, indirect. Some light goes up, some light goes down, and that's fairly common where you've got maybe prismatic or even something that's glowing. Again, this would have to be putting off a lot of light to give you a high percentage of light down. So you just want to be aware of that. And if they're going to change, here's a kind of fun little picture I took off the internet. But so here's a facility that they have these sort of glowing omnidirectional type lights that put light in all directions. And maybe they want something different, a little modern look or whatever. So they're going to go to a metal cylinder. Maybe a perfectly suitable, reasonable choice, but you need to let them know it's going to change how the space will look. And that might be exactly what they want, but it doesn't hurt to not have surprises when you're done. Taking a look at the condition of the overall fixtures and the components. You can have a new lens on this fixture, but if the interior, the sockets are all worn, you've got leakage of some kind or rust, a new lens might be hiding a lot of things. So maybe they, 2 years ago, they had someone come in and put new lamps and new lenses on, but they didn't change anything. And it turns out the fixtures are in poor shape. So you got to open up a few, just take a look, see how the fasteners are, some kinds of conditions that, the fasteners might be completely shot. Or the gasketing might be ruined. Then you want to look, we're probably not doing a lot of ballast retrofits anymore. What we're doing is either taking out fluorescent components and putting in LED components if we're retrofitting a fixture, or we're just removing the fluorescent fixtures and putting in new LED fixtures. But you do want to know some things, especially in old buildings. We still see this occasionally where we have PCBs that are a hazardous waste and need to be handled properly. Unless it says no PCBs on the ballast, you have to treat them as hazardous waste. That is for older systems, but most of the new fluorescent systems will say explicitly no PCBs. It also doesn't hurt to look just to be sure what the voltage is, whether it's 120 or 277. And unfortunately, you have to look at more than one fixture. Here's this case where we were in one room of one building and we started opening up fixtures. We looked at one just to see, and we had a 2-lamp normal ballast factor, a 2-lamp low ballast factor. The fixture next to it had a 3-lamp normal ballast factor. You don't need to necessarily know what all this means, but just to know that if you're basing your retrofit or your new measure on existing conditions, you may not. There may be reasons why the lighting is doing what it's doing, and it doesn't hurt to know that. Additionally, we saw some battery backup ballasts in there, and we even found some 277 in parts, some of the other areas. So it's good to know what you're going to be finding. And then you want to document the controls that are there. You know, occasionally we still see spaces, even though, you know, where the controls, there are no controls. It's all turned on and off at a breaker panel. You want to not have that when you're done. But it may be old dimmers. It may be occupancy sensors, photocells here and there, and mechanical time clocks. And all of these can be upgraded to newer, modern products. You also want to look for some easy wins. You know, here's a case where daylight, you know, all these lights are on, and it's obviously during the day. So you could almost put these on a time clock and just say every day at, you know, 8 o'clock or 9 o'clock, we're just going to turn them off. We don't need a sensor necessarily to do that. A photo sensor would certainly be good. What was ironic here was if you walk down this little canopy area into this space, you come into an area here where the lights are off and you actually wanted them on. So I don't know what they had going, but you know, it's something every time. So here's a case where you want to look at the room surfaces. All right, so they can have a big influence on how the space, not only the measured light levels, but also how the space looks and feels. And they can mitigate contrast and really hurt or help you on a project. And I'll show you how this might play out. So here's a model that I did of a little 2-story building with offices in the lower floor and offices in the upper floor. You know, it looks dimmer down here. And there's a reason it looks dimmer. It looks dimmer because it is dimmer. Up here, it looks brighter because it is brighter. It's the same exact lighting system applied to this model, but we just have different surface reflectances. And I don't know how many of you ever will do any modeling. You don't necessarily, and this can still impact you even if you're not doing a model, but if you do a model, typically the default reflectances on the surfaces, they just sort of, if you don't do anything, it'll come in 70% reflective ceiling, 50% reflective walls, and 20% reflective floor. So that'd be sort of a medium default. And so then if you ran a calculation based on that, you'd get about 35 average foot candles in the space. Well, if it turns out you have dark surfaces, and we'll see that this is not that uncommon, 35, 25, and 11, you're going to actually get 23 foot candles of light from the same lighting system. If you have bright surfaces, you'll actually increase the average light level. Additionally, your contrast ratios will change, and we won't get into that too much, but we have our maximum to minimum ratio, high contrast and low contrast. Usually you want lowish contrast for most commercial and industrial spaces. If you're doing restaurants and nightclubs, it's a different matter. So if you don't, so you can either be disappointed and find out it's dimmer than you thought it would be, and the client won't be happy, or you can make this, if you're on a really aggressive say maybe lead platinum or something like that, this will help you get more light with less energy, or the same amount of light with less energy. And so you think, well, who does that? You know, here's a space. This is not that uncommon. We've got a dark floor, dark carpeting, saturated color, concrete walls. You know, this is a look that we see a lot, and this is going to be very low performing from a reflectance standpoint. So you just need to know that. Here's some industrial facilities, bright surfaces. You know, they're just getting free lighting here. And it can work in lots of different kinds of spaces, you know, to make them work for lower energy. How can you find out what the reflectances are? You know, a lot of people say, well, you know, I've got beige walls, you know, that should be pretty good. This is 63% reflective. That means almost 40% of the light never bounces back off of that surface into the room, even though it looks light. So you can find out either what colors they're planning to go to. Here's 50% reflective, and this one's almost 75% reflective. Or you can measure existing conditions. And we'll just run very quickly how you would do that. So you take your light meter, you hold it onto the wall. Actually, let's see, I have a light meter right here. So you take your light meter, you'd hold it onto the wall, take a light reading, and then you hold it about a foot away from the wall. You don't want it too close, because see how I've got a shadow here? You don't want to create that shadow. You want to get far enough away that you get a general look and not much of a shadow. And then you take another reading, and then you do some simple math here, and you find out what the difference is between what you've measured, the incident light on the wall to the reflective, and that tells you the percent absorption. So yeah, you can do that in the field, and you'll be loving it. So here's a case. So when's the best time to do an audit for exterior lighting? And you're thinking, well, at night. I mean, I want to know what the light's doing at night, which is totally true. But guess what? You're going to have to go out during the day also, because at night, all the lights are on, hopefully, or you can tell if there's some aren't on, but usually that's just, you know, an easy fix. But if you've got during the day, guess what? We've got lights on during the day. That's a big problem, you know, and if they're trying to save money on energy savings, and they've got what we call in the industry day burners, you know, that's a controls issue. It could be that there's a faulty control, either campus-wide or perhaps at each fixture. Another thing that you can tell during the day, so if I go look at this fixture at night, I just see this bright glary thing and I really can't tell much. But I go back during the day and I can say, oh my gosh, look at that lens. It's when the fixture's off. It's all discolored. I'm losing a ton of light there. If I put in a new fixture or at least change the lens, I'm going to get a lot more light out of this fixture. Another thing you can tell is the condition of other components. And again, this is where you have your handy zoom lens. You can zoom in and look at things. And in this case, this isn't particularly, there's just a little aging rust, but you could see if there were elements that were faulty, and you say, well, you know, you want to put new fixtures on here, but you really need new structure. There's no reason to put new fixtures on something that's falling apart. And then some other tools that you might have if you're doing, you know, more advanced or specified auditing is a luminance meter. So the type of light meter that you normally would carry is what's called an illuminance meter, and it measures how much light falls onto a surface, and you put that on the surface and you can tell the light incident. And a luminance meter tells how much light is coming off of a surface, and it's a little bit nuanced, but we don't actually see incident light, we see reflected light. It can also help you if you're looking at glare issues. You can tell brightness of one luminaire to the next, or if there's nuisance complaints. And then data loggers. A lot of times these are handy for if you're doing controls in warehouses or other kinds of facilities where user traffic is you're wondering how much the spaces are getting used, and you can find out how much potential savings you might have if you were to deploy occupancy sensors. Spectrometer, flicker checker. We're starting to see flicker issues again with LED lights. Thermal imaging, if they're having premature failures, you can see if there's hot spots, or maybe you've got some of your mechanical HVAC systems that are blowing hot air or cold air onto components, UV meters, and then a GoPro. Sometimes people will, rather than taking lots of pictures, they'll just put on a GoPro and walk through the space and maybe make recordings, and so they can really see what's going on there. So yeah, lots of good stuff. How much light do we need? I kind of threw this in. I think in the interest of time, we'll blast through it. But, you know, they were quite happy with their 200-foot candles of diffused light back in 1939. You know, it's interesting that they've closed off the daylighting. You know, and this is back at a time when, previous to that, really all we had was daylight. The electric lights were very dim. So they figured this was progress. They could create their own daylight. And, you know, for decades, that's been the thinking. Now we're getting back to daylight, and I think that's a good thing. Again, some of these standards changed. So circa 1972, in general offices, we were wanting to see 150-foot candles, 100-foot candles, or maybe as low as 70, depending on the nature of the reading tasks. Now, this isn't the most current, but this is still fairly recent. Now we're looking at, depending on the type of reading task, 300, 400, wait, sounds like we're going the wrong direction. These are lux. So lux are basically 10 times foot candles. So this would be the equivalent of, say, 30 or 40 foot candles compared to what we saw in the early 70s of 150 or 100. So the light level recommendations, that's generally a good thing to a point. We don't want to get to where the interiors are too dim, and we're still, as an industry, trying to figure out where that sweet spot is. So people will say, you know, how much light do I need, or how much light do I want? And then the next question is, how much light will I get? And so, you know, once you've figured out how much light is appropriate, now you need to figure out how to deliver that. And, you know, it's not a one size fits all type of thing. So here's a couple of high bay fixtures. These are LED, modern high bay fixtures. And I've got lots of choices here. If I go and look at the manufacturer's literature, all of these represent a different, unique variation on this fixture. And so knowing how to pick the right one and the right quantity is, of course, that's the gig, as they say. And so, for instance, we can look at those fixtures, and they come in different lumen packages, everywhere from 9,000 lumens all the way up to 30,000 lumens, depending on which one I select. And then I can select a whole range of things like different reflector types, different lens types, voltages. In this case, there's really only one driver type, dimming, and then different color temperatures and different color rendering indexes. And I think this is, Katie, we're going to have another poll here. And I just want to find out how we want to proceed.
Do you want me to open it?
Oh, yeah, let's open it.
Okay.
And I'll go ahead and read it. So the question on CRI, color rendering index, and CCT correlated color temperatures. This isn't really this isn't a poll based on what you've learned already. This is based on how much time we want to spend on this next topic. And so I want to know, do most of the people in this group know all about color rendering and color temperature? Have you been doing lighting for a while, but could use a refresher on those two topics? Heard about them, but always get confused? Or you're new to lighting and would like to find out about what the heck I'm talking about with color temperature and color rendering. And I think that last one about a pizza class we'll leave in there, but don't probably need to know.
Okay, it's been about a minute, so I'm going to close this up and share the results here. There we go. Looks like we got to go over this, Eric.
Mm-hmm. Could use a refresher. Great.
Yep. Cool. I will close this up. There you
Thank
go.
you. All right. So qualities of lights, so both of these are two different types of architectural light fixtures that have been used in the field. And as you can see, we get pretty different results. In this bottom, these are the same cars, top to bottom, right? We just can't tell the color. Obviously, this one down here looks pretty yellow, and this one up here looks maybe whiter. But beyond that, we can see color discrimination. So what's going on there? Well, the different colors are what we call color temperature, or sometimes correlated color temperature, CCT. And every light source, whether it be a candle or daylight, natural light sources, or even electric light sources, have a different colors, and you probably noticed that. Incandescent light tends to be fairly warm. Some of the fluorescent lights that we're used to in the workplace are fairly cool, or maybe just neutral white. LEDs could be almost anything. So just because you're using LED, it doesn't make it easier. You still have to choose. So that's color temperature. We talk about on what's called the Kelvin scale. It's instead of Fahrenheit or centigrade, it's kelvins. That's a scientific scale, and it really doesn't have anything to do with how hot or cold they are. It's not a thermal thing. It's a visual thing, and I don't think we'll really get into how that works. That would be for a different class. So color rendering is not connected to color temperature, but they often come up in the same conversation. So here we have two colored area, little boxes. They're both in theory the same color temperature. They're both about 4,000 kelvins. The one up here has a high color rendering index, called CRI, and the one down here is kind of middle in, sort of not that great. And you notice the complexions are a little livelier. The colors are a little sharper in this upper one. So generally, higher color rendering is better. And that goes on a scale from just 0 to 100. And again, most of the ones below 60 or below would be considered poor. This would be the good range, and excellent above 90 or above. And we'll see, it's not always appropriate to have the highest possible color rendering, only because there's certain, shall we say, price triggers that come into bear. Often it's a little costlier to get into this range, but we'll see that may be appropriate in a second. So again, just sort of a neutral white. Here we have high pressure sodium light. We used to light our streets and our areas, the parks and everything with this. Mercury vapor was one of the early changes from incandescent, and pretty crummy. It's a greenish light and has a very poor color rendering. High pressure sodium is pretty poor. We can find high color rendering in lots of things, but mostly we're using LEDs, and they typically are going to be high. So as we move on back to our little chart here, so let's say we've decided to choose with our high bay fixture, we're going to choose a 30,000 lumen fixture. Well, we'll start right out of the gates. It's not actually 30,000 lumens. It's, anywhere from maybe 29,000 all the way down to the high teens, depending on which one you pick, right? So depending on the lensing, the reflector, the color temperature, and the color rendering. So here's one. It's 70 CRI, so it's in what we'd say good. 4,000 Kelvin, so it's sort of a neutral cool. And we get 28,000 lumens. Here's one that's 3,000 Kelvins. It's warmer, 90 CRI, but now we're only getting about 19, maybe almost 20,000 lumens. So there's a significant difference in light output. So then you're thinking, well, why don't I just use this one? And if you're lighting, say, a warehouse or some sort of industrial facility or even some sort of parking or, depending on what you're doing, this might be completely appropriate. If you were lighting, say, an airport concourse or a food court or some kind of retail, like a big box retail, even though you're getting less light, you need that high color rendering to make things look particularly good, especially in a retail setting. So that's just the price. That's the price you pay to get higher quality, is you're going to lose some lumens. We can see the 4,000 Kelvin 70 CRI product is 125 lumens per watt. The 90 CRI product that's warmer is 80 lumens per watt. So having said that, if you pick the 90 one, just thinking, well, higher has got to be better in every case, I'm going to pay more money and I'm going to get less light, when this might be completely appropriate for my project. So it's on a case-by-case basis. And these are all the files. If you do photometrics, you do modeling, all the possible choices you have for just that one fixture. It's crazy. All right, here's a little pop quiz. Try and blast through this.
Okay. Here we go.
And again, most of these are going to be you could choose more than one answer. So what are the benefits of light interior surfaces? Potential to save energy, improve visual comfort, lower contrast ratios, potential higher light levels. And isn't this just interior design? Not my area.
So far, nobody's fallen for that final option.
Good. Right. That's the only one that, yeah.
All right. I'm going to close this up. Looks like everybody's. There's the results.
Yeah. And I don't see the potential higher light levels. Did no one pick that one? I can't see.
Potential higher light levels? Yeah, they did. The yellow is really light on that bar. It's
okay. Yeah.
It scored the same as the two above it.
All right, thanks, Katie. Yeah, so all of those are right, except, and I will say a lot of people are like, well, we're just doing a lighting retrofit, or I'm just a contractor here. It doesn't hurt if you see something to at least mention it, that there might be some improvement. So yes, it may not be your area, but it doesn't hurt to just try and make a difference. All right.
There we go.
Some common retrofit applications that you're going to run across are going to be, of course, fluorescent troffers, these big squares, whether they're recessed or surface mounted, recessed cans, decorative surface mount, especially if you're doing apartment buildings or doing hotels, hospitality, high bay fixtures in industrial, or even, and then parking type lighting. So we'll take them all. Just a note here, we're going to do a little side bar here on so-called T-LEDs. Everybody's wanting to switch to LED. That makes sense. That is what is happening is LED, but there's different ways to do it. One way is just take out the old tubes, fluorescent tubes, and put in what looks like an LED tube. You know, there's still all different kinds out there. I just did a little survey before this class a week or two ago, and still seeing all these usual suspects. So not seeing so much with the metal heat sinks anymore. I think those just weren't cost effective, but we're seeing some with no diffusers. We're seeing them with diffusers with very wide ends, a lot of plastic there. And then we're seeing glass. You know, I thought one of the nice things about, if there were any nice things about the T-LEDs, is that they got away from that brittle glass that might break. But it turns out glass is a lot cheaper, and there's lots of companies that are tooled up to make 4-foot glass tubes. So they're still trying to utilize that. One thing you need to be aware of, this is a cross section of these tubes. So here's our fluorescent, our T-LED. The fluorescent tube was omnidirectional, right? It had light that came out in all directions. Most of these T-LEDs, some of them are fairly narrow. It may have luminous surfaces all around, or at least in part of it, but it only delivers light in a sort of a cone of light. Sometimes it's a fairly wide cone, but it's going to be a directional more so than the other, and just need to know that. That said, you know, for some kinds of fixtures, that may not be a problem. It could possibly be an asset if you're replacing omnidirectional. You know, you putting in a directional, you want all the light to come down anyway, so that could be a possibility. But if you have a fixture that's direct and indirect, now you would have to choose, do I want the light to go up or do I want it to go down? And that may be strange. It may change the way the space looks and feels. And it also might compromise the lighting performance. So be aware of that. There are 3 basic types of these so-called T-LEDs. UL type A, UL type B, and UL type C. UL type A doesn't require any rewiring. At least in a perfect world, you just take out that old fluorescent tube and put in the LED and walk on to the next project. We'll see that's probably not going to be the case most of the time. Then there's ones where you rewire. You got to get up there and change how the fixture's wired, bypass the ballast in pretty much every case, and then you put the T-LED in and rewire the T-LED, and that has its own issues. And then there's rewiring a remote driver, where there's instead of a ballast, you're taking out the ballast and you put in this little driver that's separate from the tube. And we'll touch on that because different entities and different utilities define kits and lamps differently and allow, they have one, if they think it's a lamp, they're going to do one either rebate or measure. If it's a kit, it goes a different direction, and you'll see here what I'm talking about in a second. So here's the big print. As Tom Waits said, the large print giveth and the small print taketh away. So here we have, this is compatible with 90% of electronic T8 ballasts. Well, that's great, including instant start, program start, rapid start, etc., all different kinds. But if you look down here in the fine print, it says, due to numerous ballast designs and topologies, this lamp should be tested on existing ballasts before mass quantities are installed. Okay, and then they say not intended for use with older dedicated voltage instant start ballasts. Well, most of the ballasts that you're going to find in the field are instant start ballast, and they're all going to be older because you're doing a retrofit. They don't really say how old is. You know, these ballasts have electronic components that degrade over time and may become unstable for the new TLED. Well, okay, so they're basically saying compatible except if you've got older product. Well, okay. Here's another one where you rewire eliminates concerns of ballast compatibility. So now we see we're worried about the ballasts. So let's just get rid of the ballasts, and now we don't have to worry whether it's compatible or not compatible, old, new, whatever. We're just getting rid of them. But there's a problem with that. Most include an integral driver, so there'd be a driver right in there, powered directly by the mains. So you get line voltage now right at those sockets, and the UL the fixture wasn't really designed for that. In addition, LED lamps may require power to be connected at one end or both ends, sometimes with an additional wire between the opposite pins. So now we're rewiring the fixture. Improper rewiring can result in product failure and or dangerous conditions such as sparking, smoking, tripping of circuit breakers, and we don't want any of that. Further, each lamp type may require either shunted or unshunted lamp holders. Well, what's this shunted and unshunted lamp holders? What are we talking about? Well, so these lamp holders, or sometimes we call them tombstones in the industry, the sockets. Well, rapid start and instant start are different. So we have a little shunt here, sometimes it's built into it, or sometimes it's a little piece of wire, or rapid start. So do not use these retrofit kit. This is from the manufacturer's literature. Warning, to avoid potential fire shock, do not use this retrofit kit in luminaires employing shunted bipin lamp holders. Well, again, as I said, instant start sockets, instant start products ballasts are the most common you'll find in the field. Note, shunted lamp holders are found only in fluorescent lumens with instant start ballast. So it's, you're basically putting in new sockets when you do that. So remote driver tubes still using the socket. So here's a case where, right, we buy the tubes, we get rid of the ballast, and we put in this driver thing that looks just like a ballast, fits in the same real estate in the fixture, uses the same screw holes and everything. And so now I have something that I know is compatible. Often they're included as a kit. Usually manufacturer supplies a proprietary driver. So that could be progress. Here's a case where we've got the power coming in to the fixture. We've pretty much gotten rid of the old ballast, and we've got our power lines hanging there. We hook them up to this little driver, and then we have a quick connect here that hooks into our TLED. And the tombstones are simply there to hold the lamp. So there's no power going to those sockets. You might still run into trouble there because I think it's UL that says even if it just touches the sockets, it's still considered a lamp. It's either UL or one other of the big entities. I can't remember which, but at any rate, that could still be problems. Plus, you remember when we looked at those old fixtures, we took the fixture apart and we saw the sockets were kind of breaking apart. They were old, they were cracked plastic. Now we're using this to hold them physically in place. It's not energized, but it's still a potential problem. Here's one that doesn't use the sockets at all. So now we're into actually what would be considered a kit as opposed to a lamp. That last one could be considered a lamp by some entities because it touches the socket. So here's a product where you've got a remote driver, and these just stick on the bottom of the fixture with magnets. You put them in place. You still have to put a tech screw in there to hold them in place, but you're not, you're just sticking them up there. They don't touch the sockets. So that's your basic kit. The downside of this kind of measure is if the fixtures are worn out, the lenses are in poor shape, I haven't changed the optics in any way. And if there were problems with the old system, I haven't solved it necessarily with this one. Usually most of these TLEDs, they try as hard as they can to look just like the fluorescent tube you took out. They don't always succeed. So I haven't necessarily improved anything. Now we have what we sort of call a complete kit, where you've got a new lens and new electronics, new drivers, new LEDs. It looks like a new fixture because it largely is. Be aware though, some of these you've got lots of different components that you have to assemble in place on a ladder. Could be tricky. And a lot of them cost almost as much as a new fixture. The other thing I would say is, so here's our old space and we're going to do this big roof floor remodel. We're gutting everything out. We're painting new carpet, new furniture, everything. Do we really want this old lighting, right? And why not have, if we've got all this new stuff, put in new lighting? Okay. So just a little word about delivered lumens compared to calculated lumens, we'll call it. And we see this particularly in decorative fixtures, but it has some bearing in any type of luminaire. So the old way that we would do photometry and measure output or calculate output from a fixture is we'd take in this case, we've got 4 1800 lumen compact fluorescent lamps, and that would give us 7,200 lumens, lamp lumens. And so here we've got these fixtures in an existing building, say a hotel, and we're going to put in two different LED products. We're not sure which one to pick. This one is only 24 watts and it's got 2,500 lumens. This one's got 22 watts. It's got, let's say, 2,000 lumens, almost 2,000 lumens. Well, this looks like the brighter one for only 2 more watts. But it's not as easy as that. So here's our 7,200 lumens from this existing fixture, the compact fluorescent. But guess what? That fixture is only 37% efficient. When I look at its photometric file, so if I take my 7,200 lumens, I'm actually only getting 2,600 delivered lumens out of that fixture into the space. Most of it just gets chewed up in reflectors and lenses. So then when we're looking at LEDs, we need to look at sort of 2 different things. Here's a spec sheet for this product, LED A we'll call it, and it said standard. It had source lumens noted, and it was 2,500 as we saw earlier. Source lumens. So that means if this fixture's 37% efficient, or let's be generous and say it's 50% efficient, we're going to lose half of those lumens. We're not going to get them. They're going to be we're going to lose them in the fixture due to inefficiencies. We don't really know. They haven't done the photometrics, so they're just basically saying we're putting in LEDs that are 2,500 lumens for you. This fixture, delivered lumens, again, 1,800, say maybe 19,000 or 1,900 lumens, they're telling you that's how much we've measured coming out of the fixture. So that's the difference between what we call absolute photometry and relative photometry. The old style was relative photometry. So here's if this has light output in lumens, this is a different fixture, but looks similar. They're saying it's 1,100 lumens. If they change anything, they have to do a whole new calculation, a whole new measurement. Some of this is how we can, earlier we talked about light distribution and how that can affect the way the space looks and how much light is delivered into the space, whether it be direct or indirect or some direct, indirect. And that's sort of true with light sources. So here's some screw-in LED product. Here's one that's directional, and this one is omnidirectional. But again, we're getting, in this case, we're getting 75 lumens per watt, but it's in a direction. This one's 95 lumens per watt, but it's all around. So if we're looking at directional, we want to be aware of what's called the beam angle, how much light is actually coming in a direction. We don't really care about light coming out at other angles, especially with, like, say, a recessed can or a track head that maybe we're retrofitting. We'll be given possibly information on what's called center beam candle power. It'll tell us how much light is coming out directly below the fixture, and then how wide the beam angle is, whether it's, you know, a wide beam or a narrow beam. So again, coming back to omnidirectional type of light sources like a compact fluorescent, a metal halide, or incandescent, if they're inside of a recessed fixture or track head, we see this a lot, all our lumens, 65 lumens coming from this compact fluorescent, if it's 50% efficient, I'm only going to get half of those, so about 35 lumens per watt. And how this relates to real world is, so here's a recessed fixture with a couple of compact fluorescent lamps in it. There's a big hole in there. That's to let heat out, because compact fluorescents are temperature sensitive. So if it gets too hot, it's going to affect its life and its performance. So if I stick my head up, you know, this is a ceiling that has acoustical tiles. If I look up above, if I stand on a ladder and look up above the ceiling, this is up inside the plenum. How can I see up there? I can see up there because all this light is escaping from the fixture. Well, all that light is light that's not coming down to where I need it. We don't need to light this plenum area. And here's, again, you can see it, that big hole there. So all that light's coming out. So if I take an omnidirectional 26 watt lamp and put in maybe a 13 watt LED, I can get considerable an advantage there from a lumen standpoint. So there's lots of LED retrofits supposedly that I can replace compact fluorescent with an LED, and it has the same pins, fits in the same fixture. I would say most of these are going to be a little fraught. I've seen cases where they work. And from an optical standpoint, they have an advantage because they take an omnidirectional, turn it into directional. But again, the large print giveth and the small print taketh away. So we've got, here they say, simply plug the replacement lamp into the existing ballast. Well, what could be simpler? Well, you have to find out if it's compatible. So you got to look at your fixture, here, look at the ballast. And in this case, I looked at it and I could see that was this was the model number. Here, sure enough, I found it on the compatibility chart and it was compatible. But it didn't work. So then I looked at the fine print and said, well, each ballast type is undergone testing. Some have undergone revisions that may change operating parameters. Performing an on-site test before installation is recommended. Well, it's a good thing I tested a couple before I bought 40 cases and hired a contractor to come in and put them all in. Here's another one. This says compatible with most fluorescent ballasts, and there's a little asterisk there. So I'm thinking, wonder what that asterisk means. Well, I've enlarged it so we can all read it. For maintenance and energy savings reasons, they recommend bypassing all ballasts for permanent operation. So if you were just going to put these in for a temporary, you know, so maybe a couple of weeks, then you can take them out, it'd be fine. But usually a retrofit is permanent. So I don't know what they're talking about there. We see a lot of these retrofit kits, and they work pretty well in many applications, and some of them have allow you to hardwire them in, and they can work. but they do change. Here we have a lens that's right at the surface of the ceiling, and here we have a recess where our light source is taken, where the light source is truly recessed. So there are recess kits where you truly recess the light source, and you'll get better optics than you had before, potentially. So that might be something you want to look for, as opposed to ones that have the lens right at the surface. Okay, moving rapidly on to high intensity discharge. We've got, only 2% of the sockets out there in the landscape are high intensity discharge, but they represent 28% of the energy use. So it's a small number, but it's a it's fertile ground if you can make it work. Hence we've seen lots of retrofit products out there. I will say I'm not a fan of most of them. A metal halide light source is a point source, and a point source allows you to have good beam control, good optics, good glare control, and when you're trying to throw light from a 70-foot tall pole 150 feet out into a parking lot, you need good beam control. In the case of LED screw-in type platforms, to make it brighter, you have to make it physically larger. And so we go from something small, but doesn't give you much light. If I need a lot more light, I have a lot bigger type of retrofit. So that's going to affect your optics. They do have some different configurations. So here's an omnidirectional. Here's one that's all the LEDs are on one side. So maybe it's going to send light out. That's possibly helpful. Here's one that looks like a big old floodlight. You put it in there, it shoots most of the light out and down. Same thing with this one. So there's different kinds that you would use in different types of fixtures. You need to be a little bit aware of that. Nothing you need to be aware of is your existing fixture have a translucent type of reflector, or is it solid metal? In the case of a translucent, this is the look that you had before, getting some light on the ceiling. With a directional retrofit, it changes the appearance, and you're not getting as much light on the ceiling. These may not be a problem for some applications, but it could be a problem in other applications. So you just need to be aware of that. Here's a case where you might recognize this is, well, it used to be called the bus tunnel. If there's a bus, now it's the transit tunnel. Trains go through there, light rail. So they had a series of surface mount and hanging and wall mount bracketed large decorative fixtures. And you can see here these hanging and the bracketed ones have a lot of light coming out the sides, designed to light the space, and they also have light coming out the bottom to send light down. The same thing was true for these surface mount, but when they retrofitted these to LED, they just could only put in the downlight part. And so now all these surfaces are dark, the fixtures are dark. Maybe not a problem, but it could be a problem. You just need, ideally, you'd anticipate that going in. Here's a case, just a little case study. We're going to run through this, and I think then we'll move on to our next portion. Here is a large industrial user. They had a big space, over 200 feet by 65 feet with 72-foot ceiling, very tall. Here's some racking, and there's a little person standing there. And they had a lot of fixtures up at the top that were old, I think, mercury vapor. And they wanted to retrofit them to LED. So, and they, we appreciate the fact that they reached out to us to say, hey, what do you think of this? What we're planning to do. So before we could say, well, how we thought about it, we decided to say, well, what would it look like if the fixtures were new, or what are your existing conditions? So they were 400 watt mercury vapor, using 465 watts total. And if they put all new lamps in them, they would have been getting about 30 foot candles in this average foot candles in this space. But they had 64 fixtures. The plan was to put in this screw-in retrofit, and they were only 160 watts. They would get 35 foot candles. So they got a little more light for a lot less energy, and pop the champagne corks, we're done. But they said, what do you think? Because the thing about this product, and most of them like this, is you have to get up there, up all 70 feet up in the air, and bypass the ballast. These are designed to run off of line voltage. So they would have had to get a technician or really an electrician up there to rewire the fixture, or not take them down and send them back up and rewire them. But at any rate, they had to do a lot of work. And they also, these are not, a $49, let's see if they work. These are, at that time, were over $300 a piece. So, there was money involved and labor. So this is the results. And so we decided to find out, well, what would happen if they put in a real fixture, a real LED fixture? This is a modestly priced one at the time. And we decided to replace them one for one, 270 watts, 80 foot candles, like a lot more light. And these are like $500 a piece, so they wouldn't be spending more money. But they had a lot of fixtures. And so I thought, well, what happens if they replace only half the fixtures? Which you can't always do, but sometimes you can, depending on the spacing and the height and a variety of things. So again, the same fixture, 227 watts, 42 foot candles, 34 fixtures. One thing we weren't looking at, which I'll share with you now. So the existing one was a lighting power density of about 2 watts per square foot. With the retrofit they had proposed, it was about 0.7 watts per square foot, so considerable savings. But when you put in every other fixture, it's 0.5 watts per square foot. Still more light, half the fixtures, money savings, at least in upfront costs, plus you're not rewiring it, you get all the benefits of a brand new fixture. All the warranty work, you just put it up, wire it, you're not fiddling around with the sockets and all that. So it doesn't hurt to take a deeper look. All right, so here's a little pop quiz. Maybe we'll just blast through this one so we don't get hung up on time. I love this fixture, by the way. Should we retrofit this fixture, put in an LED there? It's like lying on the ground. All right, before an LED lamp only retrofit, always check to be sure which of the following. A, that the fixture is in good shape, that the lamp is compatible with electronic ballasts and existing controls, that the optics are appropriate, that the utility is agreeable, and most important, that the customer has enough money.
All right, we are collecting some responses. And Eric, while we're paused for a second, we did get a question in the chat. Where is efficiency normally found on a spec sheet, if it is found at all?
Excellent. I'm eating a grape. Excellent question. It is usually you can find it in the photometrics. It's not often found in the spec sheet, although it is more and more. Sometimes you have to look pretty deep in the literature. It's usually not on a basic tear sheet, but it would be often in a detailed spec sheet. And unfortunately, manufacturers put them in all different places. So I can't tell you it's always going to be on page 2, paragraph 3.
Okay, let me close this poll here and we'll share out the results from that.
Yes. Looks like we've had good success. Yeah, so great. All right, so let's move on. Right, to the final, the fourth third of the class. So Luminaire level lighting control and network lighting controls. So why do we want to use controls at all? And there would be two main reasons. One is to save energy costs and save on maintenance costs, right? If the fixtures aren't being used when no one's around or they aren't needed, those are good things. And plus, there's a certain elegance to having the space respond to changing conditions. You know, it doesn't necessarily have to be all or nothing. Lots of, certainly in retail spaces, they want to have a certain look when they're closed. They don't want maybe people walking by, they want to have it be attractive, and that could even be true for office applications too. You know, you want to have maybe your lobbies looking different than the basic office areas. So yeah, it doesn't, I'm not suggesting a blunt instrument here. And not to put too fine a point on it, but you know, even if you have controls, yes, there's somebody in the space, but all the lights are on. So maybe we can do better. Maybe we can have something a little more nimble than that, not to discount this gentleman. And then of course, we don't want it to go the other way where, you know, you only get light right where you are. And you don't, you know, because you know, when we're in a space, we like to see the space to some degree, just so we can get a sense of it's better security and potentially better productivity and also better contrast ratios, right? So if you're looking at this, you know, even a computer monitor or whatever in a dark space, and you keep looking up and down, it's bright, dark, and that's can create eye strain. So, you know, in a modern workspace, we're used to having, or we'd like to have, the lighting respond to a whole variety of things. We would have changing intensity of light if we felt that we needed it. We might have it change based on occupancy changes, daylight changes, preference. We may have certain areas where we want it brighter, or certain areas we just want it darker, and I think that's not too much to ask. And then as the task types change, you know, if you're in a conference room and you've got one kind of meeting going, and then maybe you've got a different type of meeting, and you want a different kind of lighting. Again, so we're asking for more, and I think we're in a place where we can get more from our lighting systems. There's a whole range of control types. There's cases where just a simple on-off switch may be appropriate and allowed. Then we've got dimmers that you can control manually. We've got occupancy sensors that can take the place of wall switches, or that can be mounted on the wall or the ceiling. And then we've got daylight sensors of different kinds, and the time clocks. You know, that old picture, that old time clock, the mechanical time clock is not really allowed anymore. Most time clocks that are allowed are electronic and can be set in complicated and varying ways. You know, one of the problems that we had in the past with control systems was they were complicated to set, and you'd have lots of little dials or little dip switches or little, things that you were manipulating to get different effects. And so here's one that makes a big play out of just one button. But the problem with this one is it's almost too simple. You have to go through all these menus, and then you're like, if you want to change the occupancy delay to maybe 15 minutes, you have to push the button a couple of times to get into the set mode. Then you have to push it a couple of times to get into the occupancy set mode, and then you have to push it 7 times to get it to do 15 minutes. And then you have to back out, and then you want to test it. You need to test it, so you have to count the blinks. It's blinking back at you. You're counting blinks. And then if you want to say now set the photocell set point, you have to go do the whole thing again. And maybe you want it to be for, 16-foot candle. So you're pressing the little button 8 times. And, meanwhile, you're trying to do this while punch list guy is running through the space, and maybe carpet guys are doing something, and there's painters doing touch up, and someone's trying to hang a door. And I think that can be a problem. Let's see. Yeah. So there's all this blinking and counting and switching, and there's only one button that does everything. We're seeing more and more self-programming product, and I will say that this is progress. I think as we see more, artificial intelligence, that's not necessarily a bad thing. In this case, though, I had seen this done a couple of times. If this was something I was working with every day or even every week, I probably would find this to be easier. And this is true for a similar product. But if everything's working right and you get it, you just walk in and you just start its little program, and it'll kind of do it all. If you need to change any of the parameters, you can start to get into the weeds a little bit. But this is progress to where we're getting, to where things are taking control. We're also seeing a lot of things that interface directly with an app that you download, or some sort of graphical user interface that may come with it, that's more intuitive, that you can see and you get a sense of what you're changing and how you're changing it in real time. And so that's pretty good. So why do we use controls? I asked that very first part of this little section. Well, one reason we might do it is because we have to. Especially in Washington State, there's lots of kinds of controls that we need to use in remodels of a certain type, and certainly new construction. So daylight controls, here's a little space, a little office floor plate that maybe we're working in, and we're certainly used to seeing daylight zone. Here's the perimeter, all these windows. So we have to do something there. But guess what? We also have primary daylight zone and secondary daylight zone. And there's different things will happen, depending on where we are, how far we are from that window. Occupancy is another mandatory. We're used to doing occupancy controls in all kinds of spaces. Primarily little meeting rooms, breakout rooms, small offices, restrooms, conference rooms, that kind of thing. But now it's required in other areas too. Pretty much everywhere, unless there's a significant safety concern, and there are explicit areas where they're not allowed. And then egress. We may want to have a path of egress established so that we're not changing, or the lighting is changing or not changing depending on those conditions. So you compile that. and it makes for a very complicated control situation. So how could we maybe help that? So when we combine the control strategy, so here's an empty room with the lights are on. So I'm looking in this room and I'm seeing the lights on and nobody's in there. So that's sort of old style. Here's an empty room with the lights off, lots of daylight. It's good, but what happens in the room is occupied. So if I walk in there, do the lights come on? Here's a space where we've done it all right. So we've got daylight coming in, the lights are off, but yet we have people in the space. So that's a success. So controls, all these controls they're not, I don't want to say they're exempted, but it makes it easier. If we're doing luminaire level lighting controls, we don't have to worry about all of these, primary, secondary, occupancy, all that stuff, because all of that is sort of baked in to each fixture. Yes, each fixture has its own controls. That could never happen. But we're kind of used to that. That's something we've seen for decades now. In a little different context, each fixture has a little photocell built right onto it. And even in some interior spaces, we've started using those. That's been in the last few decades. Why weren't we able to do it before? Well, before, with the old style metal halide type fixtures, they couldn't really be turned on and off readily just because of the way they function. But when we got into fluorescent, and now particularly with LED, we can turn those on and off based on occupancy without any trouble. One of the problems with interior spaces like an office is you often have a very high fixture density, lots more fixtures, whereas like in that warehouse we looked at before, you might only have 20 fixtures in that whole, big space, whereas here we have, 20 fixtures just in this little room. So we're not used to having having controls on each fixture, but there's been things that have changed over the years. One, the control devices have gotten a lot smaller. We have sources that are more easily controlled. LEDs are potentially very easy to control. We also have higher bandwidth, right? So we can do a lot of this control. A lot of this control strategies can happen over a large area without too much trouble dealing with all the data and all the control protocols. And then we have more demanding energy codes, right? Before we didn't really have to control the lights in an office or really even in a warehouse. But now we need to start bringing control measures into bear. So the advantages of LLC is, as we kind of have been alluding, all these controls are built right into every fixture, all these sensors, and so we have more savings due to higher granularity. We'll look at that in just a second. So each strategy gets its own, each fixture, each little zone gets its own savings potential. There's no rewiring, right? So before we'd have to run all this wiring to each control device. Now we just hook the fixtures up and they talk to each other. So we're not having to wire in controls, and the ability to rezone if the use type changes. Why do we put the controls on the lighting though? Well, one reason is lighting's everywhere that people are usually. We generally have lights in occupied spaces, populated spaces. The other nice thing about lighting is it's usually high up in the space. It can see the space. So it's strategically positioned. And then third, all lighting really has power running to it. And most controls need some kind of power to function. So those things really come into play. So lighting is the logical platform for this. Let's take a look at this here's another complicated floor plan of an office, different office. And we'll look at how this might play out if every fixture had its own controls. So let's say that it's nighttime. Most of the lights are off. We've got this little egress area. Here's the elevators, and then the main sort of traffic corridors. They're just cruising at about 10%. They're just providing a little bit of glow so that, I don't know, if on the off chance that somehow somebody was in there, they would know how to get to where the elevators were or where the stairs were, or if they step off. So then let's go. Now it's the first person comes in, they're early, it's still dark out, and they come off the elevator. And so these lights go up to 90%. They don't have to go to 100%. They can go to 90%. And because someone has occupied space, whoops, gotta go back, oh well. Because someone's occupied this space, it tells the rest of the lights, hey, wait, somebody's up here. Let's turn all the lights on to 30%. It's not dark now. We got 30% light here and 90% where this person, they walk out this way, then they go to their desk. Now another person comes in and it's now daytime. The ambient light is at 30%. The traffic areas are at 90%, but in the daylight zone, they're basically off. They could be set to go to 10% if we just didn't want them dark, or they could be turned off. But the upshot is all of these are now using less power. This interior area is at 30% because there's only somebody here and somebody here, the first guy and the second person that came in. And so now we see, it's lightly occupied. Maybe it's summer, lots of people are on vacation, or it's a different, maybe flexible timing. And we've got people here, here, here. All these different spaces are occupied. They're at 90% if need be. But the daylight zone, we're saving a lot, and these lights are at 30%. So pretty granular. The way it might have been in another scenario is all the lights would be on, except for maybe this daylight zone would be down to something. So yeah, it doesn't have to be troffers. I love this picture. Here we've got someone's here, their light's on, they're not by the window, but over here we've got somebody, they're near the window, their light's basically off. There's nobody here, their light is off, but there's persons here and their light is on. So, there's lots going on. We've also got some wall washers here, and we've got some corridor lighting there where there's no daylight. Okay, I think this is the final quiz.
All righty, let's get this loaded up.
Most effective retrofit luminaire. A is energy efficient. B has appropriate color qualities. C puts light where it is needed. D has low operating costs, and E is controllable. How many of these are correct?
This one is just select one, Eric, so they have to choose.
Oh, does it?
Yeah.
Oh, weird. Okay. Well, don't select one. Select all that are appropriate if you can. I don't know if they'll let you do that.
We'll see
if
what.
it won't, then we'll just work with it. Sorry about that.
All right. Let's give it another 5 seconds.
Sorry.
And there is about a minute. All right. Here are the results. I think people were a little bit conflicted on.
Oh, yeah.
Yeah.
Well, yes, sorry for the confusion. There was supposed to be all of those are the most effective retrofit luminaire does all those things. And yeah, I would say C. A lot of people went with C, it looks like, and that might be the most important of them. if you had to pick one, the whole point of a light fixture is to actually light where you need it. Those other things might be considered gravy. So those of you who, made that choice, I get it. Yeah, so, but really it'd be all of those, ideally. And I think that might be, oh yeah, just wanted to do a little thing on some of the utilities incentive programs. And so if you're planning on a retrofit, Seattle City Light, they have their energy advisors. You could ask them questions. Puget Sound Energy has contact information, 800 number. Snohomish County PUD and Tacoma Power all have programs and for various kinds of commercial, industrial, and residential applications. So additionally, you can go to our website and you'll find links to assorted other utilities that might be throughout the region. Okay, and now I think we're done. So thank you. And if there's any questions, we'll be here for another few minutes. Otherwise, take it away, Katie.
Yeah, yep, just go ahead and type that in the chat box if you have a question. And along with the recording of this video, we'll have a copy of this presentation, so you'll be able to peruse those slides with incentives if that's something that interests you. And there we've got Eric's contact information again, just in case you have a quick question for him or an in-depth question. He'll handle those in-depth questions too. And our general email to get in touch with us. And that, I think, is it. We are powered by Seattle City Light. And when we close this webinar, there'll be a little survey. I think there's like 10 questions or 7 questions. Just real quick, tell us any thoughts you had on what we could include next time. And maybe we'll see you back again next Thursday. We've got, I think, a class every Thursday this month. That's available on our website too. And thank you again for everybody joining us. And we will see you later.
Thanks.